Hello, the Math Dog here. This video is for grades 6 or 7 and it's on the introduction to the distributive property of multiplication. This video is not to be shared or reproduced without the written consent of the creator. That's the Math Dog, myself. So recall that x to the second or x squared means x times x. It does not mean x plus x or 2x. X cubed is x times x times x. That's x multiplied by itself 3 times x cubed. This should say x cubed does not equal x plus x plus x. So x, some variable x to some power n, this is the number of times x is multiplied by itself. Or x, let's do it this way. So here x is multiplied by itself 2 times. Here x is multiplied by itself 3 times. This is different again than 3x, which means x plus x, or 2x, which means x plus x. So this is repeated. X squared, x cubed, these are repeated multiplications. 2x, 3x are repeated additions. Be sure you make that distinction. So 3x again, here's different ways you could write. You could write 3 parentheses x. When the parentheses is next to a number like that, that means multiply. The dot means multiply. You could also just write 3x, which is x plus x plus x. This is when we put a parentheses like this, we say the quantity for x squared. That's not what I mean. The quantity for x squared. So this does not mean, so a common mistake students make is they'll write this is 4x squared. That's not what it means. It means the entire quantity 4x times itself twice. So this is exponent means multiply this by itself twice. So that's 4x times 4x, which is 4 times 4 is 16. X times x is x squared. So please make that distinction. Okay, so distributive property of multiplication. Let's take a problem. 3 times the quantity. Remember, parentheses means the quantity. Spell that again. So 3 times the quantity x plus 2. Well, one way of literally interpreting this is it means you're taking 3 times this quantity x plus 2, so that's first time, second time, third time. So add it all up, you get 3x plus 6. That's what's going on, but it's not a really efficient way to look at this. What you can do is another way to do this is the way we're going to do it most time, is this is 3 times x plus 3 times 2. So you have one number here and you're multiplying it by 2, or one term here, you're multiplying by 2 terms here. So you could also make a little box here, put the 3 here, so you have 2 boxes and you have x plus 2 here. 3 times x is 3x, 3 times 2 is 6, which is 3x plus 6. Right, this is the way we're going to be doing it most time. So you don't have to make this box, but sometimes it's a good idea because again, students tend to make the mistake. They tend to do stuff like this. They'll start out with 3x, but then they'll go plus 2. They forget to multiply. You got to multiply that 3 by everything in the parentheses, each of the 2 terms in the parentheses. So let's take a look at another one here. Negative 3 times quantity x minus 7. Well, you're going to multiply the negative 3 by 2 different things here. So that's going to be negative 3. If you want, you could put a 1x there. That's negative 3 times 1x. And then that's going to be negative 3 times negative 7. That's going to be positive 21 because a negative times negative is a positive. You must pay attention to your signs. And negative 3 times 1x is negative 3x. So we get negative 3x plus 21. you could make a box, put a negative 3 out here, 1x minus 7 here, and this reason I'm doing this is this pays off when we start multiplying polynomials later. So this is negative 3x plus 21, which is what we got over here. Another example, this is negative 4x times quantity x plus 8, so I'm multiplying one multiplication there, two multiplications there. I like to call this a 1 by 2 multiplication because I have one thing here, two things here, just like this was a 1 by 2. So you're going to have two total multiplications to do. So I've got negative 4x times x. Well, we just went over x times x is x squared, so that's negative 4x squared. Negative 4x times 8, negative 4 times 8 is negative 32x. And by the way, you could write this again plus negative 32x if you like. Alright, so now let's do this problem using the box. So I have a 1 by 2, so I have a negative 4x here. I have x plus 8, or 1x plus 8 here. Negative 4x times x is negative 4x squared. Negative 4x times 8 is negative 32x, which gives us, when we take it out of the box, which we should, so that's negative 4x squared minus 32x, or negative 4x squared plus negative 32x. Alright, stop the video and do these two problems. Okay? So then, here in this first problem, we've got 4 times 3x and then 4 times 2. So we're taking 4 times quantity 3x plus 2. This is a 1 by 2. You've got one thing here, two things here, so you got two multiplications to do. So 4 times 3x is 12x. 4 times 2 is 8, so that's our final result. You could make a box. That's 4. 3x plus 2. 3x times 4 is 12x. 4 times 2 is 8. So we get 12x plus 8. Then the second question, you could put a 1 there if you like. So negative 5 times 1 is negative 5. X times x is x squared. Remember, you got two separate multiplications due here. And then you've got negative 5x times negative 2. You must pay attention to the negative signs. That's a positive 10x. So that's your final result. You could use a box here. Negative 5x, 1x minus 2. When you use the box, the advantage is you remember you got two multiplications due, because again, students like to forget to multiply to negative 5x times negative 2. So negative 5x times 1x is negative 5x squared. Negative 5x times negative 2 is 10x. Taking it out, that's actually plus there, so that's negative 5x squared plus 10x. Okay, before we move on, let's look at some things with variables and exponents. So note that x squared times x cubed could be broken down to x squared is x times x. And I didn't show the multiplication sign there, but it is implied that it's there. I don't have to show that little dot. Well, x cubed is x times x times x. Well, notice how many x's we have multiplied repeatedly. We have 5. So this is x to the 5th. Notice you could, when you're taking x squared times x cubed, you could have taken x to the 2 plus 3 and figured it out that way. Now, notice that is different than x squared to the 3rd. This means x squared multiplied by itself 3 times. So that's x squared times x squared times x squared, which is then, notice you have x squared is x times x, so you have a total of 6 x's multiplied together. That's x to the 6th. So in this case, when you have a power, you multiply the exponents, but when you have something like a base, we call it a base, x is a base, 2 to the 2nd, or let's just say x is 2. 2 to the 2nd times 2 to the 3rd. Well, you could literally say, okay, well that's 2 times 2, and then this is 2 times 2 times 2, which is 2 multiplied by itself 5 times. 2 times 2 is 4, times 2 is 8, times 2 is 16, times 2 is 32. You could also say, though, that's 2 to the 2 plus 3, which is 2 to the 5th, and you need to know that 2 to the 5th is 32 because that shows up a lot. So in the case of this other one here, let's say we had 2 to the second to the third. Well, that literally means 2 squared times 2 squared times 2 squared. Well, 2 squared, 2 times 2 is 4. 4 times 4 is 16, times 4 is 64. You could also, though, have written this 2 to the 6th, which is 64, because, well, 2 to the 5th times 2 to the 1st is 2 to the 6th, which is 64. So then x to the 4th times x to the 5th, this literally means you have x multiplied by itself a total of 9 times, so this is x to the 9th. This, though, means x to the 4th times itself 5 times, so notice when you have it like this is literally x to the 4 plus 4 plus 4 plus 4 plus 4, which is x to the 20th. But if you catch on here, that's x to the 20th. You could just, when you have a power, you multiply the exponents. When you have a power, a base to something times what we call a base to something else, you can add the exponents. So going forward in the next couple questions, please note particularly this one, those examples. Okay, so in this case I have negative 3x times the quantity x squared plus 7x minus 2. Well, here I have a 1 by 3. I have 3 multiplications to do. So that could be, you could put a 1 if you wanted there. You don't have to. So this first multiplication, and let's make a box here. So my first multiplication is that. Well, x times x squared, if I want that to be, I could treat that as x to the first. Well, here's an x multiplied by 2 more x's, that's x cubed. Then we have a coefficient of negative 3. So then I have a 7x here, I could put a 7x to first. Negative 3 times 7 is negative 21. X times x is x squared, or x to the first times x first makes x to the second. Then I have minus 2, so I have negative 3 times negative 2, that's a positive 6. And then I have that x that I can't forget about. So my answer is negative 3x cubed minus 21x squared plus 6x. You want to get to the point where you can do this mentally in your head without having to do all this, but you do need, it does help to actually sometimes draw these like distributor wires or lines or curves to the different parts to remind yourself you have 3 multiplications due, because a lot of people forget to do this last multiplication. So here we have a, next one we have a 1 by 2. So I have 2 multiplications to do. So I have 5x squared, x cubed, negative 6x. So 5x squared times x cubed, well that's going to be 5x squared times x cubed. We just did that. That's x to the 5th, because I have 2 x's multiplied here, times 3 more x's makes 5 x's multiplied together. Then 5 times negative 6 is negative 30. X squared times x, there's 2 of them here, 1 of them here, that's a total of 3 x's multiplied together. So our final answer is 5x to the 5th minus 30x cubed. Okay, then I want you to stop the video and do these, then restart it and check to see if you agree with what I get. Okay, so here I have a 1 by 3. I have 3 multiplications to do. Okay, I'll put it in a box. So negative 4 x to the 4th times x cubed, that's 4 x's multiplied there, 3 more x's multiplied there for a total of x to the 7th. So I have negative 4x to the 7th. Then I have negative 4 times negative 2 makes positive 8. X to the 4th times x, well that's 4 x's multiplied here, another x multiplied there makes x to the 5th. Then I have negative 4 times 7 is negative 28, and then I have times an x to the 4th. So my final answer is negative 4x to the 7th plus 8x to the 5th minus 28x to the 4th. And my last example is a 1 by 2, so I have 2 multiplications to do. So let's put that in a box. So I have 8 times x to the 9th times x to the 5th. Well, I have 9 x's here times 5 more x's here makes 14 x's. So then I have 8 times -2 is -16. X to the 9th times x squared, well, that's 9 x's here, 2 x's here makes 11 x's. So my final answer is 8x to the 14th minus 16x to the 11th. Okay, then just a little word problem where you could use a distributive property. A hardware store chain has a total of 18 stores. Each store has 2 managers, 3 cashiers, 5 salesmen. How many of each type of employee does the chain have? Well, one way is you just multiply 18 by everything here, but that's really a distributive property problem. So we could write this using the methodology we've done in this video up to this point. I could write 18 stores. Each store has 2 managers, that's 2m, 2 times m, plus 3 times c, plus 5 times s. So then we would multiply this out. We have 3 multiplications to do. This is a 1 by 3. 18 times 2 is 36. So I have 36 managers, plus 18 times 3 is 54. So I have 54 cashiers in the 18 stores total. 18 times 5 is 90. So I have a total of 90 salesmen. So these are called variables, or in this case, M represents 1 manager, C represents 5 cashiers. I'm sorry, C represents a cashier, S represents a salesman. So 3C means 3 cashiers. So if I have 18 stores, 3 cashiers each, I have a total of 54 cashiers. And this is the end of the video.